I'm a JVM engineer. I worked at IBM for a very long time doing JVMs, right? Way back before they even became famous. So I've been doing JVMs for a long time. I've also led DevOps teams, and I do developer relations now, which is this, coming out and talking to you about what's going on, telling you things you should be aware of, and getting feedback. And so that's my job, which is great because I get to meet all you guys, right? I work for this company. Anybody know who we are? Everybody? Way one or two? Cool. Okay. So we're the guys that run this, Maven Central. Everybody heard of Maven Central? Yes. Well, now you know it's run by Sonatype. It's been run by Sonatype since the beginning. We just really don't talk about it. Okay. So this talk is a little bit of Java. But this talk is about three things. Right? We're going to talk about AI. And what the effect is on you as developers. We're going to look at cybercrime and the effect on you as developers and what that brings in. And we're going to cover a little bit about legislation, sort of summary. We're not going to go through any of the legal stuff because it's boring and we have more of the important things to do. Okay. So let's start with journeys. We are, almost all of us, as engineers, Java engineers, doing something about taking some code to cloud. Might be Kubernetes, might be something else, but you're on a journey. You've got some code and you've got to get it delivered. And that's complicated, right? Modern delivery is code. Code is hard. There are many tools you have to use. Many tools. That's hardly any of the many tools. There are thousands of tools that we have to use. Right? It makes life hard and complicated for us. And within this is what's the SDLC, Software Development Lifecycle. So you have the tools, you have the process, right? So you have what? The elements like source code and repositories and build systems and all those things. They are Software Development Lifecycle. They are the bits and pieces, whichever ones you choose. And then hidden away in all this is a thing called the software supply chain. And I'll come back to that in a minute. Right? So we have a lot in our heads. As developers, our job is really complicated. It's much more complicated than it's ever been. And I'm just going to make it more complicated for you. Right? Because we're going to add AI into the mix. Right? Now, who here is using ChatGPT? Or something similar. Okay. How many of you are using it even if your company says you shouldn't? Yeah. Okay. Right. Okay. So I asked ChatGPT what are the top Java frameworks and things, and it gave me a list, some of which I'm not quite sure that should be on there, but that's ChatGPT for you. Yeah. There's also things like Copilot. So AI is already here, right? We know AI is here. We know AI is a great thing for developers as tools, right? We're quite used to ChatGPT as a tool to help us. How many of you using Copilot, things like that? Yeah, hopefully you're all playing with it. If there's one takeaway from here, which I don't have a slide for, is that as a developer, you must now have an opinion on AI-based development tools. You've got to be able to decide what works and what doesn't work and why it's good and why it's bad. Because these tools have to be part of your life, because they always, there's this thing about, are these tools going to replace you? And the answer is no, these tools are not going to replace you as a developer. What's going to replace you as a developer is another developer who knows how to use those tools. That is the reality today. So even if your company isn't letting you use it inside, you still have to put it on your resume as something you play with. So you need to do that, even to your own time. It is important, whatever tools you use, and whatever tools we put on that list today, there'll be 10 tomorrow that are brand new. You can walk around this, you can look at all the talks that are happening here, you can go to all the booths. AI is a big thing, isn't it? It'll net out. We'll have a few things that are really good, but you have to be, and if not expert, you have to be experienced in these tools because they're going to make a difference. Right? Now, I said there's not much Java in here. This is probably the only slide which has got Java in it. So as a Java developer, you'll be sitting there going, how do I do AI stuff? So we've got the tools out the way. They're easy. The question is, how do you get AI into your system? How do you ingest AI? Because pretty much everybody I talk to says somebody in their business, some developer, often a Java developer, is being asked how to connect AI to the data in their databases to give competitive advantage. Every single company is trying to figure out how to get the best competitive advantage they can. And so everybody's panicking, right? Because at the end of the day, the data usually sits probably with the software, with the back-end guys, the Java guys. You probably have the best relationship with that. So when we have that conversation, there's this unnatural assumption that the tool you're going to use to write AI with data that's connected to a Java application is going to be Java. And the sorry state is right now that's not true. Right? There are things coming. I mean, you know, LangChain, Quarkus LangChain, Spring AI, we are developing them. But Java has only just started in this. I mean, it's not that it hasn't been recognized. There are things like FFI, foreign function and memory API, which is designed to give Java and outside Java, the other runtimes, a very fast path, so you can access memory and call functions without the overhead that we've traditionally had. So that's there. There's things like Tornado VM, which is trying to figure out how to get Java to run on GPUs. But they are not particularly mainstream. We're getting there, we're coming there. Unfortunately, the thing that you as a Java developer will have to get your head around is that almost all the AI stuff is not happening in Java. Guess which programming language is going to be the one you're going to be learning to do this? Python, yes. So those guys, your Python developers, hey, welcome to the club, right? So that's the reality. And part of the reality is that Python is very good at the interop with all the binary things, features, whether it's whatever functions are out there. There's lots of functions that are written in other languages that Python can deal with. When we get this, we may be able to do that, but so much, and I'll bring up a page later on, so much of the AI world is built on Python already. So it's not something that's going to change overnight. So your new reality is go learn ChatGPT and start learning how to use Python and stuff like that. Now, you don't have to drop straight into Python. Some of these tools have really good bindings to the models and things that are out there. And there's lots of examples. So you could do it in Java, but at some point, you'll end up going, I need to do things differently. As your expertise grows, you'll realize that you have to do Python. Right. So that's the Java piece. The problems that we all face in this new space, the AI, the security legislation, stem from the software supply chain. So as a developer, you're probably, the dependencies and libraries box is probably the one that you might connect to. You go, I have dependencies, somebody else's code, I consume somebody else's code. Dependencies. So software supply chain is about dependencies. And to a degree that is true. That's something we all care about. But the thought process and the bigger process that you get into is a lot more than just the dependencies. So obviously there's the code you write, that's the blue box. Then there's the dependencies. And then there's how you test things, right? How do you do integration? What's your deployment processes, right? How do you do security compliance? Do you have processes, right? Maintenance updates. What's your release life cycle? What do you do with bugs? And how do you say to people that you're finished? This is end of life. Now, internally within a company, you might fluff over some of these, but as you'll see in a minute, these other boxes are going to have a real impact on your life. So 2024, we're beginning to see that there are three things. I've already mentioned them, but these are existential pressures on us. These are things that are coming that we have no control over, they're going to change how we do things, how we behave as developers, what we code, how we code it. And the thing is, if we get this wrong, then your company goes out of business. It either goes out of business because it's not competitive, it goes out of business because it's hacked to death, it goes out of business because it breaks some laws. And this is all new stuff. So what I'm going to do is take you through these three things. We're going to look at AI, we're going to look at cybercrime, we're going to look at legislation, and they sort of come together. So let's start here with AI. So I think AI is fun. It's been one of the newest, funniest things to enjoy, right? There's a lot of contention about AI, but let's be honest, it's a fabulous thing. You're all sitting here going, I've got to learn about AI. You know, whether here or some other talk, you're going to learn about AI. There are more tools that I can say that I can stick at, and they come out. Everybody's doing them for everything. And some of them are really, really clever. Some of them sound like they shouldn't work. Maybe they're just too far off, and some look very practical. And out of that, this is from, I think this is from NVIDIA. NVIDIA, obviously being people who provide GPUs, have cottoned onto the fact years ago that GPUs or TPUs, there are variations of those hardware that are very good at running neural networks. That's their business. And so they enable that. So who here plays games on a PC? Anybody PC gamers? Okay. So PC gamer, you have a GPU in the back, right? Graphics processing unit's probably about that big, weighs a little bit. Server ones, the ones that NVIDIA produce, they're the size of a car. They are super powerful. And these things are what are enabling so much of this rise of AI. Right? So with those amazing models that we get, these billion and trillion parameter models, you get all this fabulous benefit. Right? It's brilliant. But don't be deceived. It's not that simple. As you're going to find when you start doing this for yourself, and I'm going to take you through some examples, it is amazing, but it's not easy. And it's something that affects the way that will affect the way that we develop. So let's go through an example. So generative AI, which is the new thing that we're using, which is opposite foundational AIs, generative AIs, I can ask it something. So I said, give me an image to support the conjecture that, what does it say, that computer can think is no more interesting than the question of whether a submarine can swim. And it gives me what's in white. And then I take that and I say, create an image, and I get an image, right? So it's interpreted those words, expanded it, and I have an image, right? And for a lot of us to go, that's cool, that's wonderful, right? But they're designed to be creative. That what they do is what they were trained to do. And you have to peel back the training to make it to understand what's really going on here, right? So a generative AI system is one that learns to generate more objects that look like data it was trained on. So let's just explore that. So you probably seen images like this, not particularly this image, but an image with little boxes telling you what something is. This is a foundational AI type exercise. It's what you do is you have lots of images and you have some text that's associated with the image, which is created by a human being that says box, cat, giraffe. And the AI learns to associate that text with that image. And then when you give it an image, it can roughly guess what you've got. Okay, so that's the core. That's foundation AIs. Generative AIs are built on that. But look at this. If I say I gave it that image of a giraffe, and I went to this thing called actually I went to ChatGPT first and said describe this image, and it gave me the words in white. You want images similar to one provided, which appear to be a photo featuring African wildlife with an overlay of object recognition boxes and percentages. So the AI that's good at understanding what's in an image could spot exactly what it would have been given. What a giraffe with boxes, identifying boxes. When asked to produce it, when an image generation AI, generative AI, is asked to produce the image, what do I get? I get a really, really realistic looking set of animals, mostly, and the boxes are non-existent. The reason for that is that the AI did not have enough data. It didn't have enough data about what those boxes look like. So it couldn't synthesize them because it didn't have data. What you get out of this is that fundamentally these AIs that we're relying on are very lossy. Text to image is amazing, image to text is amazing, but by definition, it's always going to be very lossy. And we'll play with that in a second. Okay. So I can give it an image, like ChatGPT, and it says, look, the scene is reminiscent of a classic movie scene from E.T. the Extraterrestrial. It's amazing. It's spotted where the image came from. It's from E.T. and it's quite right. Perfect. Right. So I say, describe the content in more detail because I want to regenerate it. It gives me 200 odd words. So I go to DALL-E and I go create the image. And I get this one. Very similar. I ask a bunch of other AIs. And yeah, well, one of them, the one in the middle, the text was, I think, from a ChatGPT one, which said, this is copyright infringement. I'm not generating an image, which is like tick. But you can see the others. Right. Now, think about this. How many people here, how many of you know what the Mona Lisa looks like? You've all seen a picture of the Mona Lisa? Really famous picture? Okay. I mean, you can pick anything famous. Can you describe it in enough detail that somebody who's never seen it could draw a picture of it? No. You can't do that. Right? And that's what happens here. What you've got to understand with all of these AIs is that they are fundamentally lossy. They're very, very powerful and we can guide them towards certain things, but ultimately they're very lossy. So you can't get a picture that looks just like one you created. I'm sure you could probably train it to be a bit more specific, but it's really, really hard. Right? Let me show you this in more detail. There is a point to this conversation. Right. So here's a friend of mine, and for some reason, which I can't remember, I have a picture from Passengers, and we're going to play with it. But let's play with this lossy piece. So I take this image of him, and I've got two routes, right? I can take an image and I can transform it. So I put different words in, I get different transformations, right? But you see, they're all different. I tried this. I wanted to create a cartoon vision of Olympi, my friend, and put in that image of Passengers. So I take an image of him and I go, okay, turn this image into a person in a spacesuit. Sorry. And I get the first image. Looks really good. It's brilliant. Love it. So then I say, remove the helmet. Wait, run the wrong way. I may have got the other way. But I think, no, I don't remove the helmet. I say, turn them to face right. That's it. So I get them to turn them to face right. And do I get the same thing? No. right? I ask it to remove the helmet, and it does, but then it turns him into a small boy. And then eventually I go, okay, well, that's good. Maybe if we just turned him slightly to the right, that would work. I could use that. And I ask, and I get a completely different image. What's going on is this description problem. I can't type in enough words to be certain that I can control what the output is going to be. Right? Bear with me, more to go. So I've got that image, and I go, okay, I want to add it into this thing, picture of passengers. I'd like them to be there, please. That'd be fun, right? So I thought, well, a copyright infringement. So the first thing is, I get one of the tools to create a vague image. You can see it's very similar, different style, right? They're great at that. Got that. Happy with that. I then want to take the image and take him out. So I go to a different tool. So you see I'm racking up the tools here. Go to a different tool, and it's Adobe Firefly, and I say, remove the male character. And it identifies the humans, and it takes them both out. Right? See what's happening here? I'm communicating with these AIs, and I'm not getting what I expect. Right? Getting something similar gets really hard, right? So, okay, fine, deal with that. There's another thing that Adobe Firefly could do. It could do generative fill. So it can fill in the empty spaces with things from the surrounding space. And if you look at it, you probably wouldn't notice it's just slightly wrong, but it's good enough. Right? It's good enough for me. And then I post him in just using a graphics program. Right. So some things to think about. These AI tools, whatever we talk, they're mapping tools. Right? They're going from one to the other. They're very, very clever, but they're certainly not infallible. And they're really hard to get to where you want them to be. So training is incredibly important, but specific training. So if I want to have something that can take a human being around it and move it around and do amazing things with it, I have to build an AI specifically to do that. I have a base with generative AI to do that, but I have to put lots of effort in. And the chances are that I'm going to have multiple AI tools in my tool chain to get what I want, because they have different skills. So that's going to affect how we all develop, because you're going to have a lot more complexity in your system. Right? What else have we got to say? You start to get locked in, because the choices of AI that you use, wherever they come from, your data, your control, your teaching, is only going to be relevant to that model. And sometimes those models change underneath you, especially if they're like on the web. And so you've got to start thinking about how you, Mr. Java developer, are going to build systems that consume AI, but are also going to be managed and tested so that you get the right output, right? And AI gets used for really bad things. You can read there's some really good stuff it does. There's also really bad things. And sometimes it's inadvertent, sometimes it's deliberate, but in either way, it always means that you also have to have human curators who are looking at the output to make sure that it is not biased, that it is not racist, or that it actually does what it's supposed to be. So if you think you can go off and create a chat GPT agent with one model from Hugging Face and think it will work, then good. I said fail, right? Because there are so many things that could go wrong with these models. Right, I think I've said all that. Yeah, right. So it's just adds to your supply chain. So this model that I had described, the behavior and the actions that we have when we're delivering software, the bits and pieces, the choices, those things, well, now add some more boxes. Right? So you've got control. The AIs that you're using have to be under control. You have to know where they came from. partly so you know what they do, but there are other reasons you can imagine for controlling these things. You've got to train them. So you've got to get training data. Where are you going to put the training data? What happens when the model changes? There's a whole process there that your QA guys are going to struggle with. And then this continuous retraining and evaluation, because you need human beings to guide it. And I think I've said most of those. Yes, so most of the models are going to be in Python, or not Python. Most of the models require some sort of Python connection. And so if you're a Java developer, you need to get to meet your Python friends, because it's going to be a two-way street. You're going to teach them more about software engineering and back-end stuff. They're going to teach you about data science and how to use AI. Yeah. You need to know where the AI comes from, because you don't know how it's trained. We'll talk about some bad things about AI in a minute. But your choices lock you in, because you have to train it, and you have to get data, and you have to train it, and you have to make it work. And if the AI model changes, then you have to retrain. And I think I've said that as well. Yeah. And then you have the human safety net, which is the curated thing, which is not automatable by definition. Human beings have to be involved. So yeah, life gets a lot more complicated, because you've now got more stuff to do. Right. So let's add on the bad stuff. So as Java developers who are here to learn how to add AI to your system, there's loads of people out there who will teach you the specifics. You've got to think about the consequences to your organization. So the first thing is that whole thing about your software supply chain process. Your SDLC, your CI/CD systems get more complicated. Right? And then top of that is this stuff. Right? So cybercrime is beyond control. I talk about this often. Right now, this year, cybercrime is worth to the bad guys something like $6 trillion. And you look at that number and you go, what does that mean? What does 6 trillion mean? Well, I could buy 600 odd aircraft carriers from the US. There aren't 600 in the world. There's only 50 in the world. Can you imagine 600 aircraft carriers? It's ridiculous. And if that doesn't really compute, how about this one? The Empire State Building, that big iconic thing in New York, is worth about 2 billion. You'd have to buy 3,000 of them to spend your money. Right? And if that doesn't fit, how about this one? If cybercrime was a country, by GDP, it'd be the third largest country in the world. That's how much money is at stake. So you can see why it is that we're getting legislation that's going to trickle down to you guys about how we manage things, how we manage AI, how we manage software in general. Because money talks. Yes. I did that calculation this morning. I think it's right. Right? I think, however you look at it, it's a stupid amount of money. And if that isn't worse, if that isn't bad enough, the drivers here from a financial point of view are extreme, but that's not the biggest challenge. The biggest challenge for all of us is that it's churned from being something that's about money to being something that's about cyber warfare. So you may have read science fiction stories, about, well, there's a physical war going on and there'll be a cyber attack and stuff like that. And that is happening. But the problem we've realized is that these cyber attacks, these warfare, using all the technologies and techniques the bad guys have to steal your money, they use them to get into your systems. And by that, I mean your company systems, they get into your infrastructure, you name it, they get in there, because what they've realized is they can use all this fabulous technology that the bad guys use to compromise your systems. And if they can compromise your systems, they can use that to influence them. So what they're looking to do is it affect your economy? So every nation state is doing this now. It's become a thing, right? There's none of this old thing about, oh, well, it only happens when there's a war, or it's something you read in the papers or the movies. Cyber warfare, which is lowercase w, excuse me, is here. The objective of the bad guys is to compromise your systems and change them. So if you're like a shipping company, you may try and get in and change the shipping labels. Hey, I can route things to a different place. I could steal them by routing them to a different place, but I upset your economy. If I can turn off all the traffic lights in the city, it causes chaos. It hits economies. Right? It's also a wonderful way of demonstrating the weapon works. So what we're seeing is more and more of this becoming a steady state. Excuse me. But it's connected to this desire is you've got to understand that whereas before you might have gone, yeah, my company's tiny, we're never going to be targeted. And the simple answer is, it doesn't matter how small you are. It's about who you know, what you're connected to. You're a small company, you're a small consultancy, you have inroads into other companies, you've got email contacts, they'll find them, exploit them. The bottom line is that every single one of you, whatever company you're working for, whatever organization, you are potentially a target. And some of these things come to my other talk tomorrow, and I'll tell you how some of these attacks work. But basically, we are all at risk. And guess what? AI has been used to drive some of this stuff. And the way that they're trying to get at you, they're either going to try and phish you, which is the traditional thing, or they're going to go after your software supply chain. All those dependencies that you choose, they're figuring out how to compromise them. So they used to just wait till vulnerabilities turned up, but now we have active bad guys trying to get into the open source projects that you're consuming when you download things. And there's lots of ways of doing them, but the effective net is that you get things like this. You may have heard about this one recently, an XZ bug, right? Problem came up last couple of weeks. It's a very, very long sting. Basically, the XZ is a compression library used in Linux all over the place. What happened? The bad guys forced the XZ guy who owned this to give up ownership. They basically wrote him horrible emails and said he should stop doing what he's doing, and he gave up, relinquished ownership of this stuff, and then it got used to bypass things. So this thing, if you have XZ at the patch on, if this is on your system and it's the right level, and your SSH protocols, any of your security, can be bypassed. And it was achieved by what's called a friendly or benevolent stranger attack. You can go read this, right? But basically it's this poor guy who's being told by a bunch of what are called sock puppets, hence the pictures. Some of them are real human beings. We're seeing more of them turning into bots. So they're being pressured to give up control, and that gives up control of open source projects, and then eventually bad stuff happens to open source project, and it comes down to you. Right? And then there's AI. AI is now another big weapon because it's fabulous at being able to fake out people and do those things. Right? 9 in 10 companies are at risk of cyber attacks by AI. Right? If you think about it, it makes sense because these tools are brilliant. They can, they can fake human beings. They can definitely occasionally fake an email to you that you'll give into. So you can see, and it's automatic, no human beings involved. Right? And then, how about this? AI-generated polymorphic malware. So this is Python code generated by an AI that is designed that after it's done its first thing, it changes its shape so it can't be detected. So it could make a web call, and then change itself so it hasn't got any web calling code in it. And then in which case the scanners can't find that. Right? This is what you're up against. And then the models that we're using, the models that you're going to use, the models that you're going to pull down and you're going to use Python with or or LangChain, where do they come from? Well, they come from Hugging Face mostly. There's a whole bunch of things in problems there, different story. But these things are risky. These things come down to us and they have risk associated with them. And some of that risk is more than just, oh yeah, it's got the wrong license. It's got active challenges with it. Okay. And then there's a thing called AI poisoning. So the models that you download, those ChatGPT things you interact with that work perfectly well, can be configured, can be trained. So if run in a different environment, can let bad things happen. So you can have models on Hugging Face that could conceptually be poisoned, so that when they were deployed in production, could open a backdoor to your systems. Right? AI, managing AI, keeping all this safe, is all part of the software development lifecycle. It's all part of the software supply chain, and it's going to fall to you guys to be part of that story. So this horrible set of things that we care about already, which we have to care about, right, now gets one more: AI legal governance. Right. So I feel like what's before was very much like, as developers, we would sort of like run around. There'd be no fences. It'd be like, it's wonderful, it's going to be brilliant, and we can do whatever we want. And what's happening is that literally fences are being put around because of these things that are not our problem, not our fault. More and more, this requirement is coming down to you as developers. So legislation is the next thing. I just got a small list. Believe me, this is nothing. There's legislation on how you develop software. There's legislation on how you use AI. There's legislation on how you control AI. There's legislation on pretty much every part of the software development lifecycle. Right? And they've all got different big sticks and carrots. So in the US, they're going to say, if you don't follow these rules, you can't do business with the US. In the EU, they say, if you fail these rules, then we'll fine you, and maybe someone will go to prison. There are other rules, other countries, but it's become a big thing. Everybody sees the benefit, the power, but that means things are coming down to us. And if I was to summarize it, try and summarize all these things, I'd say this is sort of close. Right, the first one is really weird. Anybody here heard of S-bombs? A few. Okay, tentative S-bomb. Okay, so we'll talk about S-bomb later on. But if you look at the words that I've written, there are some things: evidence, automation, demonstration, proof. So that wonderful build system that you've put together, that's got Jenkins and GitHub Actions and stuff like that, cool, wonderful, you can carry on doing that. You just have to prove that it's not been tampered with. And you need to prove that who can control it and what can do things, right? So when I say the whole point of this talk was sort of reimagining Java, well, maybe not the way you're expecting, right? But this stuff is coming to you. These are the sorts of rules that are coming down, and they'll be more or less depending on which country you're in, who you're working with, what type of government, what type of industry you're working with. But they're all coming down to these sorts of things, which is all about control and proof. Now, there's a lot of people working to try and help, right? Sonotype works with OpenSSF and others. We're all trying to figure out how to help you, right? So you're not on your own, but it's still slow because it takes a lot for us to figure out what the answers are going to be. But you need to pay attention too. So this isn't a problem that you can run away from, because you are front and center in all of this. Okay. These little boxes, supply chains. We'll come to a little supply chains in a minute. the supply chain, which is that I have a piece of code and I package it and I give it to you and you take it and you give it to somebody else or whatever. That whole process of delivering software, supply chain, is the number one attack vector for the bad guys in terms of compromising systems, because it's so easy to do. And as you can see by the graph, the number, but the rate is just going through the roof. We're just finding them so much, so often. And one of the reasons that this is happening is because you guys don't pay attention. You are the people that choose open source software. Right? You are the people that go, I need an XML parser, or I need this, or I need this, or I need this. And you may have controls on your company about licensing and stuff like that, but you instigate it. You're the one that says, I'm going to pick that thing because that's what I want. Right? 96% of the time that you pick something, that thing, that version has got a vulnerability. Right? And there's probably a better version out there because you're not paying attention. You're going, oh, I need an XML parser or whatever. Go to Google, cut and paste. So because you don't pay attention, because you don't pick the better version, you allow vulnerabilities in which allow the bad guys to attack. And you have this idea that if there are vulnerabilities, I think somebody will fix it. It's not my problem. Somebody will fix it. Because you assume that all the open source that's out there, somebody's looking after it. 16% of Java projects are maintained. 16%. 6% of JavaScript stuff is maintained. 11% of all open source projects are maintained. That means 90% of the code that you use in your application, part of the frameworks, 90% on average, nobody's maintaining it. So you're using all this stuff that's old, and it's going to come and bite you. Oh, by the way, when we talk about maintained, we're using a definition from the Linux Foundation. And maintained means one update every 90 days. So maintained doesn't even mean fixed. It means, there was something happened. So that's frightening. So all the source that you are using and all the AI stuff that you're going to go and get, the models and the Python code and stuff like that, majority of it is unmaintained. And it's going to come down to you to look at it. Because of this, because the only time that anybody puts any attention to picking up software is right that first point, and that's you. Because after this, your organization will just bump the versions if there's a problem with it. But if you were to pay more attention and pick something that was better, then you'd have less problems. You'd be fixing less vulnerable, upgrading less often. You'd be more secure, right? Because we would then not have things like this. Log4Shell. Log4Shell, yes, everybody remembers Log4Shell, unless you're a brand new Java developer. We're still 22% of downloads from Maven Central for Log4Shell, of Log4j, 22% are still for ones with vulnerabilities in. So if you're a Java developer in here and you're using Log4j, right, only one quarter of you, 1/5 of you, still have vulnerable versions, and you may not even know about it. Right? And then when you add that our Java supply chains get Python code, so you probably don't do this as a Java developer. When you download a model, quite often a model from Hugging Face will have things that says, oh, there's some Python code to install. Right? And that's just common. So now that software supply chain that you've got, which includes AI models and Java code, and has got a bunch of vulnerabilities because you're not picking the right ones, is now going to get a bunch of Python code, and Python has a lot more attacks and a lot more vulnerabilities than Java ever did. And so now you're bringing in a new world into your pipeline. And you're the software engineers in this story, because most of Python developers, not all of them for sure, but most of them are data scientists first. And this is not their space. This is your space. So when you look at this chain, all these pieces, all these things coming to you, you've got to realize that all of that, right, all of that sits under you too. So your software supply chain relies on dependencies, and every one of your dependencies has a software supply chain, and every one of your dependencies, the people behind it, where they exist, are making the same sorts of choices, right? And they may not be making choices that you like, but they are. So as a Java developer, you go to your POM or your Gradle file over it, and you've got a list of dependencies, and that's where you start, right? And you may not think more than that, but you know that you get more downloads than that when you install something. You get more than the 5 or 6 you've got, right? On average, come on, a Java application has 150 dependencies because it fans out. Everything you depend on has its own dependencies, and you get a transitive tree. You're now relying on 150 supply chains from other people who are also looking at legislation and are also looking at, maybe we can include AI, and are looking at all that stuff, right? So what you've got to realize is that this bit being your code, 10%, the bit that you write, depends on all this other code, which is just full of shocks. This is about reimagining Java. And it isn't about reimagining Java, the language. It's reimagining Java, the people, how we do things, right? The objective is for you to walk away going, there's a problem, I need to go see whether we're in this situation, right? You've got to start looking, first off, you've got to understand that the complexity of what you're getting into is more than you expected and is going to get more complicated, because it isn't just about pulling down a dependency and adding some data and magic happening. You have more work to do, and that will come down to you. You have your data scientists, your Python guys to talk to, because you're going to need them. So you need to build relationships there, right? If you've got AI models off the web, you are in a bad place unless you can prove the provenance of that model. Hey, that's something you hadn't even thought about. How are you going to do that? Maybe that means you're going to have to start building these models and training them from scratch. That gets more complicated. You need data. Where's that going to come from? The problem gets bigger, right? And because of these new security issues, nobody's there really thinking about them, because AppSec guys aren't going to think about it. It's going to come down to you as developers. You're the ones most likely to be on the front door of dealing with these problems, right? What I was going to say. The software supply chain security, this reimagining of how we produce Java starts with you, right? It starts with the tools. There are good tools out there. It starts with you looking at your software composition analysis tools. It starts with you looking at the tools that you use to find vulnerabilities. And it's up to you to start having an understanding of what they do, because there are some tools out there that are very good at finding just basic vulnerabilities. There are tools out there that can do the transitive thing. They can find vulnerabilities in things like that. There are tools out there that can scan like antivirus and find bad code. You've got to decide which of those ones you're using, because if you're using the poorest tools, you're at risk. but you probably don't know which one you're using. Right? Right? The good news, the good news is, I said S-bombs. S-bomb is a new thing that's coming your way. Another thing for you to put into your system. It stands for the software bill of materials. So often we rely on tools to work out what it is we've got. We use these SCA tools to delve into the thing. It's down over here. We delve into the thing and work out what we've got. What S-bombs are going to do, and you're going to be forced to, you'll be going to be required to produce an S-bomb. S-bombs are bills of materials. Look, I've got a better picture. When you buy something, you normally get some list of packaging on the side, don't you? Wouldn't it be good if you could get a list of packaging from a component that you're using that tells you what its dependencies are and what its vulnerabilities are? S-bombs are like packaging, list of contents, bill of materials. And with those bills of materials, you now have a really good understanding of what's inside the software you're relying on, so that you don't have to hope that your SCA tools are good enough to find the contents, right? So governments are going to ask you to produce S-bombs because S-bombs are the proof of the contents. And then you can give that proof of the contents to somebody else and they can scan it and they can say, hey, you've got vulnerabilities or not. That makes life a lot easier for us. It makes governments happy. And as I said, that means it's another thing that you're going to put on your list. I didn't learn anything about Java. I said, well, yeah, because there's not much to learn about Java. Right? What you're learning is that AI is much more complicated than you realize. And that as a software engineer, you've got a lot more things coming your way that you didn't realize. It is going to come to you. You have no choice. Nobody else is going to do it. Some of it's going to be fun because of the AI stuff, but it isn't as simple as you thought. And unfortunately, the legislation coming down is going to get there too. So you're going to find that a lot of the automation systems you have will over time be rewritten because A, you're going to plug AI into them, and B, legally, you're going to be having to provide evidence chains and things like that. So now is a good time to start getting your head around what you do today and say, how am I going to incorporate it? How am I going to add in that Python-driven model? How's that going to connect? Right, you've got those sort of things to worry about. Now, I'm going to give you a plug here. If anybody's interested, I have it on a piece of paper. I'm plugging a trial if you're interested. Sonotype does produce actually some really good SCA tools, but we don't normally give them out as trials because they're normally pretty expensive. But we have a version that's designed for development teams because of the sort of problems that we're talking about. So if you're interested in experimenting and seeing just how vulnerable your application is using our tools, then sign up for the trial. I have it on paper if you want to give it like that. This other thing down here, right? Well, that's mine. So I'm trying to crowdsource a book. I'm looking for people who'd like to share some wisdom. And I know there's a lot here, but as a Java developer, you learned something that made your life better. And I'm looking for people to voluntarily give me that wisdom by going to this website, 10xjava.dev, and creating an issue about things that they learnt. And I'm looking for people who could give me a one-liner. The best advice I got was this, or something bigger, maybe a whole chapter on how to use a tool effectively. What we're trying to do is build a book for the community, because it will be published under Fujay, where everybody gets a little bit more help on being a better developer with different teams. And I think when you look at all the changes that are coming down for all of us, it's about time that we built something like that so that there's a bit more advice floating around rather than ad hoc conversations. So that's that one, I think. Yeah. So I'll sum up because then I'll be finished. 3 things coming your way. Some are good, some are bad, some are just life. So artificial intelligence, which is thing. Unfortunately, as we said, it's not mostly a Java thing. It's still mostly a Python thing, right? The hottest new programming language is English, which is perfect. So there's new stuff to learn. Don't worry about that, right? But it's bringing radical changes to the way we do software development. Cybercrime, which is out of control, starts with the software supply chain, which is how you build your software, how you choose your dependencies. And we need you to do that more in a more considered way. You've got to choose dependencies more wisely. It's a hard thing to do, but we're helping with tools beginning to appear there. But that comes down to you. If you can choose safer software at the beginning, then the chores you have through your application's life, keep patching it, will lessen, because you can actually choose better software. Right? S-bombs, right? And then legislation. It is not going away. It is coming. It's a matter of time. Some of it is already law. New law is coming. It's about control. It's about management. It's about proof. Right? And for some of these laws, if you get it wrong, not only do you go out of business, somebody goes to jail. And on that end, I'll stop there. Thank you.